Okay, before I get started on the actual CAD work, might I advise, if you're doing a lot of work like this, pick up yourself a pair of calipers, or set of calipers, um, so that, I picked these up for like, I don't know, 15 bucks or something at a wholesale tool company, but this is about 20 years ago. But the point is, you can find some pretty inexpensive calipers out there that are halfway decent quality. Because these are nice and solid. They're not flimsy or anything. But again, they were from 15 years ago, so who knows what the quality is these days for such inexpensive calipers. These aren't Starretts or anything. These aren't several $100 calipers or anything. But it's certainly an essential tool to have. I'm starting. Let me show you this. That's our LED candle, and I'm going to use this as the starting point for my drawing because some of the components in there I'm going to actually reuse in this design. So I usually will start with a pre-existing drawing and just erase all the parts I don't need and keep the parts that I do need. So one of the first steps I always go through in a case like this, and you can see I can get the camera adjusted here. You can see here that I'm in this project. I'm not going to need this. I'm not going to need the base and so forth. Let me go ahead and hide those layers. And the top. Okay. And the bottom. And the stand. Now, I'm going to do a different battery because, again, this design is going to use this holder. So I'm going to have to dimension these parts and do a CAD mock-up of them. It doesn't have to be precise, but enough to, where, like on this battery holder, we want to know what the exact, very close to the exact dimensions are on it, as much as possible. It's like this 9-volt battery I've got shown here. This 9-volt battery I've got shown here, it's just a crude approximation, and that's all you need. But I'm going to, certainly reuse some of these LEDs here, these resistors here, and these switches in this design. Everything else is going to pretty much change. So, but the first step, to go through is taking your calipers and getting the dimensions. Now this happens to be approximately 1/8 of an inch. Which, if you've never used calipers before, here, let me put it on close-up mode, fire mode. If you've never used calipers before, this scale here reads out in 100ths of an inch. So, and you can see you've got basically 10 100ths of an inch as you read up along that scale, and you read it based upon wherever this is. So to measure this like that, I don't know if you can see it or not, and I usually have to use a magnifying glass, but that's got 1/100th of an inch exposed, and then it's a little over that, and you read the little over part on the dial here, starting from 0 going up to 30, and 1/8 of an inch is 125 mil. Okay, so, there's your 100, and here's your 25, and that's about 27 is what it's reading. And again, it's probably there's going to be some error in it. Well, actually, it's, now that I put some pressure on it, it's only about 122 mil. But again, approximately 1/8 of an inch is good enough. Because this is an 1/8 inch wall tube, and I can measure the overall diameter of the tube at, you see 1 inch, so that's 1,000. There's a 7 there, but the 8 isn't quite showing on the scale there. if you can see that. So that's 1700, and then you read this, and this says 55. So that's pretty much very close to 1 3/4 of an inch, 1.75 inch. You know, or 1755 mil is what it is. And again, it's good when you're doing this to actually use exact measurements, because you don't want to, you know, come out wrong on your part, because, you know, the 3D printing's not precise to begin with, and you got to kind of plan around your tolerances. So that's why I do that. And well, actually, this isn't the part I'm using. It just got in the way. It's a great example, but that's how to use calipers. But this is the part we're going to actually use for this project. So, and this is actually less than 100 mil, if you see that. And in fact, it's about 75 mil in diameter. It's a little over 1/16 of an inch, which is 63 mil. So that gives you that idea. So, you know, it's pretty thin walled, you know, 75 mil. And the overall diameter, this is PVC tube, by the way. That other piece I had is acrylic, but this happens to be big enough for what I need to do here. I'd rather have it acrylic, but this, you know, without ordering an expensive piece of tube here, it you know, it's just I had this lying around. It's part of my vacuum system. You know, I got a shop wide vacuum system. You know, with those clear tubes it has on it. You know, those big long, you know, tubes that you stick together to hook to the CVS, central vacuum system. That's what this is. Anyway, the diameter is, you know, just about 2 inches. You know, it's a little under 2 inches. So, you know, it's about, you know, 1950. You know, 1,995 or 80 mil, 82 mil. So, you know, that's a pretty good size. And the height, I'm not sure, because I'm probably going to cut this down, so I'm not going to worry about the height right now, but I can always stretch it out. So let me go ahead and take care of that here. I'm going to, you know, I'll put this over in computer mode eventually, but right now, since I'm doing things with the calipers, it's easier for me to do this than to put it on, you know, screen capture mode. So I'm going to start by drawing a circle here, and I'm going to go ahead and position that at 0, 0, and we know we need 1975, 1.982 was what it was, right? So, and the inner wall, I'm going to grab this offset tool, and we want that to be 75 mil, 0.075 inch. So I'm going to go ahead and put that in there, and that gives us that. Okay, so at this point, I'm going to go ahead and do an extrusion on this, and I'll just make it, say, 2 inches arbitrarily. So you can see there's our tube. Okay, now the next piece I need to diagram is, of course, our battery holder. Now, when this thing has batteries in it, and it's always a good idea if you can, I don't know if I got any spare batteries lying here next to me. I usually just build in a tolerance for error on things like this. It's always a good idea if you can to actually have like the real batteries in it, because it'll stick out just a little bit. But right here, we're talking about this thing being 1.25, about almost exactly 1.25 inches. And again, it's okay usually when I'm doing dimensions like this, on something like this, for it to be too big. You know, it's okay if if we actually round it up a little bit instead of round it down. But like on that tube, we don't want to do that, because again, that could actually, we want an exact measurement on that as much as possible. But on this, we just care to make sure that whatever we design to hold this battery holder, that it's not too small to where when you stick it in there, it's not going to fit. So it's good to actually leave a little tolerance to make it actually a little bigger, but it's at least 1.25 inches. And so we're going to want to keep it to at least 1.25 inches, but I'd probably make it about even 1/1300ths, 1.3 inch, you know, to give it just that extra little tolerance may not be a bad idea, and you know that's there, because again, this 3D printer too, you know, since I don't have it dialed in, will actually print things a little bit fat, you know, for lack of a better word. In other words, if you think something's going to be that wide, it's actually going to be that wide. So, you know, you got to take that into account right now. Again, you can, you know, tweak the thing and get it to where it is more precise than that, but you're also likely going to have more issues with, you know, your layers not building up thick enough and things like that. That's one of the reasons I haven't tweaked my printer yet, because I just know, you know, that could be kind of a headache, you know, trying to get all those parameters dialed in properly. But at any rate, to get back to our measurement here, you know, this on this dimension is only actually 1.1 inch, but again, I let my caliper slip. No, it's actually, you know, pretty much the same, about 1 3/4 of an inch. I'll see if I can get some batteries here to test this out with. I thought I had some old ones lying around. I know I do. I just don't know what I did with them. I don't know, I got some bad old batteries lying around here somewhere. I just can't seem to find them. Using some experiment somewhere. There's plenty of triple A's lying around here. I don't seem to have any double A's. Well, I got one. It's proof that I got more, because I know I had several up there. Oh, here they are. Jeez, right in front of me. Okay. Now I'm going to go ahead and put some of these dead old batteries in here just so we can get a better measurement. It's a good idea to be safer than sorry. Especially if you're using a program like Rhino, because it's a real pain in the behind to go change things. If you made a mistake, and you'll probably no doubt see that, how you have to go back and undo things, it's better to use a parametric CAD system, you know, like SolidWorks or something like that, if you've got 5 or 10 grand lying around to invest in it. But I do actually have an old version of Solid Edge I could use, but you know, it's so old. I'm more accustomed to Rhino. But yeah, okay, so with the batteries in it, though, it's, you know, still 1.3 inches would be safe, even with the batteries in it, because it doesn't make that big of a difference. But you know, it's just a good practice to look into it, because you don't want to find out later you're wrong. So about 1.3 by 1.3 inch, and then my caliper is out into long mode here, which I usually use my wooden ruler for this. Let me get my magnifying glass here so I can read the thing. It's you know, pretty much 4.3 inch is enough. It's just slightly under 4.3 inch. So, you know, that's a good enough measurement. So, you know, 1.3 by 1.3 by 4.3, you know, would be adequate for this as a representation. Now, this I'll just kind of draw off to the side. Up here, 1.3, 1.3, 1.3. It's one of the things I love about this program is being, man, I'm in this enter C for close. It's one of the things I love about this program is being able to, you know, enter my measurements and then place my line. You know, it's kind of cool. Anyway, so that's our base for a square, and we don't have to worry about anything, but let's extrude it to 4.3 inch. Okay, so now you know, we've got our new battery holder, which I'm going to go ahead and make that red. And I'll put it on the battery layer here. Okay, so and anyway, that's our tube, and I'm going to go ahead and assign that a color. I'll make it blue and add a little bit of transparency and gloss to it. Actually, I want to add a lot of transparency to it. Okay. Alright, so that's got our, battery. Now, when we're working with this battery, we got to remember there are wires sticking out of it. And so when we get to that point, that's a pretty good distance too. We want to make sure we got clearance in whatever housing we design for those wires to snug in there. Probably about a quarter to half an inch clearance, because remember, these wires are going to kind of like coil up in it whatever we do. So because you got to have a length for the holder to come out. So we'll probably have to have maybe even a half an inch sealing on this thing so that it fits in there. I do know that on this project that one of the things I'm probably going to do is on the base of this candle, I'm probably going to have a cup that goes in there, and then it's something that goes on top and screws in. So anyway, thought I'd get you started. Next we'll go into the CAD work itself.